Okay, so there was one thing I wanted to point out to you about synthetic substitution that I left for today on purpose, and it actually has to do with what you did in the rewind, that problem that you looked at. So when you did all of your work here, you found that the remainder is 0. So you have p of 2 is equal to 0. Now, the reason that I wanted to save this for today is because this is a skill that we're going to need in the next couple of days when we actually solve these polynomials to try to figure out what makes them 0. So when you get 0 at the end, when you're doing synthetic substitution, in essence, you have found an answer. You have found a root. So that's an exciting thing. Now, a lot of times, or all the times yesterday when we did this, none of those were 0, and that was on purpose to show you that it doesn't happen all the time. But again, you're kind of looking as you should be keyed in on is that 0 or not, all right? And if it is, great, then we're going to use that in terms of solving these in a couple of days. So I just wanted to bring that up, and that's noticed here in the remainder theorem. Again, I know that there's a lot of words going on here, but the idea is that if you get a 0 as your remainder, you have found a root, and you can use that to factor. So I won't get into using the x minus a part today, but just know that we're going to use this factor theorem when we solve these polynomials, okay? So just another skill that you're going to need when we do that, all right? Now, that also means that we're going to need to know how to factor. Now, you learned how to factor quadratic trinomials, the difference of two squares before Christmas. But in terms of what we're going to do today at the beginning of the lecture is that I want to make sure you know how to factor another way. And this way is called, as you can see, factor by grouping. All right, now if you just look at this polynomial, first if you were to name it, we have a degree of 3, so we know it's going to be cubic, and I have 4 terms, and that is called a cubic polynomial with 4 terms. And you have never factored any polynomials like this. And first, if I asked you to look at it, you would notice that nothing or none of these terms have anything in common besides a 1. So if I asked you to factor right now, you would have no idea, and that's okay. So I'm going to teach you that there is a way that maybe you can factor this. So I say maybe because you always have to have this check, all right, while you're doing this process. So the first thing you want to do, because it says factor by grouping, is you want to group the terms. It's in standard form, okay? So I'm going to group the first 2 terms together and the second 2 terms together. So I put those parentheses to show how I'm going to treat this polynomial. The first 2 terms are x cubed and x squared. And if I factor out what they have in common, you can always factor out up to the lowest exponent. So I see a 3, I see a 2, so that's why I factored out x squared. So again, factoring is really just a way of dividing. So if I take out x squared, what is left is x minus 1. Again, a mental check to make sure that you did this correctly. You can distribute x squared times x is x cubed, x squared times negative 1 is negative x squared. So we actually haven't changed anything, but we have factored out something they have in common. Now I'm going to do the same process for negative 25x and positive 25. Now they both don't have an x, so I cannot factor out the variable. However, they do have 25, so I'm going to factor out negative 25. All right? Now I factor out negative 25 for a reason. All right? I'll show you why later, why it has to be negative 25 and not a positive 25. So I factored out a negative. So again, if I divide negative 25x divided by negative 25, that leaves me with x. If I do the same thing with 25, that leaves me with minus 1. All right, and so here is why I had to factor out the negative 25. If you look in the parentheses here, right, if you look in the parentheses, both of these say x minus 1. If I would have factored out positive 25, then inside this second parentheses would be negative x plus 1, which is not the same. In order to continue to use factor by grouping, these in the parentheses, I'm going to underline them, these must be the same. If you're doing this and they're not the same, you must stop and you cannot factor by grouping. So I want to repeat that because it is so important. While you're doing this, if you're going in the process and the things that are underlined in red are not exactly the same, I mean exactly the same, then you cannot proceed. Now they are the same, So I'm going to go ahead and continue, and this is where I'm going to bring down what I factored out. So I factored out x squared minus 25. So I put those together to make a factor. Now the reason I'm only going to bring down one x minus 1 is because they share it. I don't need to bring down two x minus 1s. They both share that factor, so I'm just going to bring that down. So I want to be very clear. This is not the answer, but I'm going to say that it is the answer in terms of something new, right, in terms of factor by grouping. We are done with the factor by grouping part. If I were to distribute x squared times x and negative 1, negative 25 times x and negative 1. If I were to distribute those binomials like we did last week, I would get what I have at the beginning. So I have not changed the original polynomial. I have just factored it. All right, I just factored it so it's a little bit kind of nicer. Okay? Now, again, this is not done, but in terms of the new stuff I'm teaching you, this is finished. This is factored by grouping. Now, because it's not done, I'll show you that this x squared minus 25 is something we discussed last semester. That is called the difference of two perfect squares. So it will factor as x minus 5 times x plus 5. And then I'm going to bring down that x minus 1. All right? Now we are finished, and this is fully factored. Again, I cannot stress it enough. What I have at the very bottom here, these three factors all multiplied together, is exactly the same as what I began with. It's exactly the same as x cubed minus x squared minus 25x plus 25. One is factored, one is not. And again, this whole process just helps us when we want to solve these polynomials. So this is a skill, factor by grouping. That is a skill that you need to know when we start solving these polynomials. So if you take a look at the two from your at your board slide, I want to be very clear. Number one is just like the example we did. All right, it should work just like that. Please refer to the example we did together. Number two is a little bit challenging because if you notice, we have a 2 at the very beginning. So be careful about how you factor out. So you want to factor out common factors. All right, so I'm going to let you guys try those.